All right, so I'm going to walk you through this practice exam problem that was about the Starnes family visiting Yellowstone Park and hoping to see Old Faithful erupt. You turned this in on a Saturday or a Sunday midnight assignment. So first of all, there is a dot plot of 20 wait times from the previous week. So it gives you some idea of how long you might have to wait if you just pulled up and did not see any eruption and you were wondering, well, how long am I going to have to wait till the next one? Do we have time to go get lunch? Something like that. So these are the wait times from the last week. And so part A, and I've highlighted an important phrase, asks you that based on this sample of 20, you are supposed to only look at this graph of 20 dots and estimate the probability that they're going to miss the next eruption. And there was something in there about it's going to take them 70 minutes to run some sort of errand. So they want to know the probability that your wait time is less than 70. So you look at the graph, you see 70, and you count 1, 2, 3 dots that are less than 70. So it's a very simple arithmetic calculation that 3 dots out of 20 dots are less than 70. So it's 3 out of 20, which is 15%. The 3/20 would give you the work credit. And you could probably just leave that as your final answer, or if you want to get it in a decimal, it'd be 0.15. The second part says, well, that point that's down there at 51, which is going to be important later down here, 51, has a z-score of negative 2.56, and they wanted you to interpret this value. Well, the negative is important. Many of you did not make any mention as to what the negative meant, and so you got a ding. The correct answer would be that a wait time of 51 minutes would be 2.56 standard deviations below the mean wait time. That's what the negative tells you, is that you're below average. And then make sure you do say wait time. Don't just say below average, but say below the average wait time. That would give you the context credit as well. In part C, we have new information. So apparently, if you would happen to know how long the previous eruption lasted, you might have a better prediction on what the wait time is going to be. If you just go by the dot plot, that's not, that's some information. You can see what wait times generally are, but apparently knowing the duration gives us a little more advantage in predicting how long it's going to be until the next one happens. And that's because there is a weak to moderate positive association between duration of the previous eruption and the wait time until the next one. So the next question is asking us, based on the fact that, I guess maybe, there's some people leaving, and so they say, hey, how long did that last one last? Somebody might say, it was about 3 minutes. So let's just assume that they got some information that the last eruption was less than 3 minutes. It says I'm highlighting it, based on that fact and the positive association. That gives you a clue as to how it's going to be scored. They're telling you that you have to answer based on the fact that the previous one was less than 3 and this positive association. Now, many of you got keyed into that and you had a great answer and you said, well, because there's a positive association, high duration values are associated with high wait times and low duration values are associated with low wait times. And this is a low wait time. So we would expect, or this is a low eruption time, excuse me. And so if it's a low eruption time, we would expect a low waiting time. And that would be a good argument based on what they gave you. Now, additionally, you could say, well, let's make a prediction. If it was 3 exactly, now it says less, but what if it was 3 exactly? If we were to make a prediction off of this linear regression, it looks like it's going to be in the mid to low 60s. So that would be another argument, is that if we're going to use this as our prediction, predicting less than 3 is going to give us less than 70. And that would be a great way to justify your answer. And you're basing it off of this positive association in the scatter plot. Part D, you had to estimate or calculate and then interpret the residual. I think they're saying estimate because if you don't have to use a calculator this year, then you might just look at the graph and try to say, well, how far away is that dot from the line? Looks like it's about 5 maybe. And because it's below the line though, the residual would be -5. So they allowed you just to kind of ballpark it and say -5. -4, whatever that would be estimated. Now, some of you actually used the equation that you can figure out with the slope and y-intercept and calculated it, and I believe it was like -4.66 or something. So either saying about -5 or saying -4.66, either one would be correct. And then the interpretation just would be one of those things where you'd want to say again that the actual wait time was about 5 below the predicted wait time. The predicted wait time would be up here on the line. The actual wait time is where the blue dot is. So you can say it two different ways. You can say the model overestimated it by about 5, or you can say the actual wait time was about 5 below what was estimated. You can say it a couple different ways. And then the last question was certainly a very different question. The point that we've been talking about, this 2.2, 51, he says it should be classified as an outlier if you're just looking at wait time alone. But when you consider duration and wait time, it's not an outlier. And so to describe that, well, it's real easy just to go up to the top here. Here's what 51 looks like if you just look at wait time alone. So this would be a great place to go to write your explanation. Why is 51 considered an outlier? Well, I would just argue based on the definition, it is far away from the rest of the data, or from the bulk of the data. You can maybe say it that way, because there's this other one out here. And that would be a great answer, just basing it off the dot plot. Now, if you wanted to go ahead, because they gave you Q3, and you can figure out the IQR, and some of you just figured out the IQR, took 1.5 times that, subtracted it from Q1, and figured out that, oh, there's some boundary or fence. I think it's actually more like right in here. And I think both of those maybe turn out to be outliers, as I recall. So you can compute it just with arithmetic and actually prove that 51 is less than a distance of 1.5 IQRs from Q1. Or you can just say it's way far away from the bulk of the data. Either one would be a good explanation. But then when you get to considering both duration and wait time, well, now we got to look at the scatter plot. So here's our point 2.2, 51 down here. And why is it not an outlier when you consider duration and wait time? Well, one way to say it is just that it's still in line. It's fairly much in line with the rest of the data. It follows the same trend, the same positive association. It's right in line with it, and so it's really not considered an outlier just from kind of a feel or a sight perspective. But then if you really want to get kind of mathy, and this is really the answer they were hoping you would say, well, how far away is it from the line? Well, we said it was about 5. Is 5, a distance of 5, unusual? Unusually far from the line? Well, not if you look at this one and some other ones. There are lots of other ones that are probably farther away than 5. In fact, this green number right here, this is the standard deviation of all the residuals. In other words, this is the average distance from the line. Well, 5 isn't even 1 standard deviation from the line. And so you could even argue from that standpoint that that residual was less than 1 standard deviation away from the least squares line, and that's not considered very far. It's not really an outlier. Now, I did notice something kind of weird. Some of you were talking about the trend in the wait times, and that's why this point was an outlier, because it didn't follow the trend in the wait times. Well, when you look at wait times, there's not really a trend. That's not the right word. We don't have a trend. We have gaps, and we have space between 51 and the rest of the data. That's something you can talk about. But trend is not a word that you use with a dot plot. Trend is more of a word that you might use with a scatter plot, where something is going up or down, that sort of thing. And especially maybe if you had a lapsed time, like 1 minute, 2 minutes, 3 minutes, a lapsed time or years or something, and you could see how there's a trend over time of something. So don't use the word trend with a dot plot, but you would be able to use the word trend with a scatter plot. So that's just a quick run through of that problem and some of the common mistakes that I saw. So as always, let me know if you have any other questions, and I'll see you in class.